Ladies and gentlemen, welcome back to math. Remember, last class we left off with triangles. We were dealing with hypotenuse, opposite, and adjacent. Okay. Today we're going to continue that a little further. Okay. Notice that I already have one on the board. Okay. Notice I already labeled it. I chose C to be our theta. That means that across from theta is our opposite. Across from the 90 degrees is our hypotenuse. And then we have our adjacent on the bottom. Okay? Now, today we're going to take it a little further. Today, if we wanted to find all three of angle C or angle theta, okay? Keep in mind, there's three things you need to know. Okay? There's something called sine, which is we have sine, okay, cosine, and tangent, okay? Usually, always revolves around trigonometry, okay, when it comes to triangles, to solve for a specific angle, okay? Now, for all three of these categories, okay, we have sine. There's a specific way to find that angle, okay, that you're looking for. If you're looking for sine of angle C, okay, so sine of angle C, let's do a little more space here. This way I can have, all right, so we have sine of angle C, which is, okay, now for sine of angle C, we have, let me see what colors did I use. I used purple for hypotenuse, blue for opposite, and red for adjacent. All right, in order to solve for angle C, okay, not necessarily angle C, but let's put it as angle theta. Okay, sine of angle theta, which in this case is obviously C. But in order to solve for it, we have to put here, we have to put opposite, okay, opposite over our hypotenuse, okay. Maybe it might not make sense right now, but keep in mind, as long as you follow these rules, okay, these are pretty much rules to help you solve for angles. So in order to solve for sine of theta, we have to divide opposite, whatever the value is, divided by our hypotenuse. Okay? If we wanted to solve for cosine of theta, okay, cosine of angle theta, which in this case is C, okay, we use, let me make another dash here, we use adjacent, okay, adjacent over hypotenuse. Let's use the color we use for hypotenuse here. This one makes it a lot easier for you guys. So for hypotenuse, I use purple. So adjacent over hypotenuse. Okay. Again, keep in mind, it might not make sense right now. I'm going to put some values in there. Okay. For now, just write the rules. You need to memorize the rules. Okay. And the last one is, we have tangent. Okay. Tangent of angle theta, which is opposite over adjacent. Okay. Make sure you have all three rules. Make sure you have your triangle or our triangle here. labeled, okay, with all three sides. Now, here's the fun part, okay? If I were to have another triangle here, okay, or we can even use the same one. There's just another color here so you can see the difference. Let's say we have this triangle here. First of all, we know it's a right triangle because it has the square in there. Okay, makes a 90-degree angle. If we have this right angle or this right triangle, if I were to say the opposite is 10, okay? Do it on the inside. 10, I did it sideways, okay? So we have 10 for the opposite. The hypotenuse is 22, and our adjacent is 2. Okay? Keep in mind, today, all we're going to do is we're going to plug it in. Okay, that's all we're doing. So for the first one, if I wanted to find sine of theta, again, we will say sine of angle C, okay, because that's where theta is, equals, which is opposite. If you guys remember, for opposite, we have 10 over our hypotenuse, which is 22. Okay, and that's it. We're not going to solve it. That's all I want for now. Okay, just to get you in that habit of plugging it in. Okay, so if you wanted to find cosine, we would say cosine of angle C equals, again, adjacent, which is 2, over our hypotenuse, which is 22. And then finally, okay, tangent of angle C equals opposite, which is 10, over adjacent, which is 2. Okay, and we are done. Okay, again, all we did was substitute opposite hypotenuse on each one of these and adjacent for actual numbers that were given to us in the triangle, okay, actual values. I'm going to do another one, okay, where I'm going to draw another triangle. I'm going to give you theta somewhere in there, okay? This time you have to label it for yourself. Remember, these ones don't change ever. That's the rule. You might have opposite and adjacent change here on the triangle, depending what theta is, okay? But the actual rules never change. Whatever theta is, you still use the same ones, okay? The values might change because, again, opposite and adjacent might change, but it's always the same rules, okay? All right, so here's the one for you guys, okay? Make sure you write it down, write everything down. All right, so now I'm assuming everybody has it. If you didn't, go ahead and rewind the video a little and pause it if you have to write it all down. All right, guys, so your triangle is, let's do one of each, okay, just to get the hang of it. We have A, B, C, okay. Might choose another color here. So you guys can see it a little better. Okay, there's our right triangle. We have A, B, and C. We have 9, 3, and 1. Okay, theta is going to be on B. Okay, again, you have to label it opposite, adjacent, hypotenuse, and then also give me sine, cosine, and tangent for this triangle. Okay, I'm also going to do one more. This time, theta is over here. We have x, y, and z. Okay? Again, we have 12, 4, and 2. Okay? Again, remember, you have two triangles. You have to label them. You have to tell me, which ones are hypotheses, which ones are adjacent, your hypotenuse. Also, give me sine, cosine, and tangent for theta. All right, you don't have to solve for it. All you have to do is plug it in. All right, guys. So make sure you submit your answers as soon as you're done watching the video. Okay? And I'll be waiting for your email.